Welcome to today's topic, Vectors 1. And in this topic, the specific objectives are define vector and scalar, use vector notation, represent vectors both single and combined geometrically, identify equivalent vectors, add vectors, multiply vectors by scalars, define position vector and column vector, find magnitude of a vector, find midpoint of a vector, define translation as a transformation. Now, we want to introduce by defining some of these terms what we call a vector. A vector is a quantity with both magnitude and direction. Example is acceleration, velocity, and force. When we talk about magnitude, we mean the size. That is it, you can measure it. A scalar quantity is a quantity with magnitude only, e.g. mass, temperature, and time. In my diagram here, I've tried to show what we mean by magnitude. The pink color, it shows the direction of movement of this vector. This is a vector. And this one shows the magnitude. Magnitude means the length of it. You can measure the length from here up to here. This is the magnitude. And this one shows the direction. So the length of this line, as I've said, shows the magnitude. The length is the magnitude, and the arrowhead points towards a given direction, as I've explained. Vector notation. When we talk about vector notation, is the presentation of a vector. A vector AB is represented in the form AB with an arrow above, or AB in bold form. When we talk about a magnitude, how do you represent a magnitude? A magnitude, that is the length you present in this form. This is how a magnitude is represented. So the magnitude is just the length, as I've said. The length of A to B is the magnitude of that vector. Now, when we talk about equivalent vectors are vectors that have equal magnitude and the same direction. So for the vectors to be equivalent, that means they must be pointing towards the same direction and they must have same magnitude. For instance, if you see this vector V and vector W, the two vectors, if you measure the length from here to here and the length from here to here, you find they have the same length, and therefore meaning they have the same magnitude. And they are pointing towards the same direction. If you look at them, they are pointing towards the same direction, and therefore they are equivalent vectors. The two vectors BQ and this other vector RS, they are also equivalent. But you see here, I've used a point 32, and this is another point here, and we have 0.12, and this is 0.00, 0.32, 0.12, and 0.44. In this, they are pointing. This is the arrow. This is the arrow. They are pointing towards the same direction. So if they are pointing towards the same direction, now the work here is to find the magnitude. And to find the magnitude, we use what we call the distance formula, which we shall discuss later in the topic. Distance formula, when you use, you'll find the magnitude of this to be root of 13 as the magnitude. And this RS also has a magnitude of root 13. So you realize, because 3 squared, which is 9, plus 2 squared, which is 4, 9 plus 4 is 13, the root. And this one, we are going to learn on how to find a vector in column form, and then from there you are able to find the magnitude. So we shall discuss that later. but you realize that the magnitude of both is root of 13, and therefore now that they are pointing towards the same direction and they also have the same magnitude as we have said, then that means they are equivalent vectors. So vectors are only equivalent if they have equal magnitude and they are pointing towards the same direction. Now we talk about addition of vectors. A movement on a straight line from point A to B can be represented using a vector. That movement is called a displacement. Now we consider a displacement like this one is a displacement of from V to O, and we have also U here. So if we have OU, it is U vector, and UV is V vector, then that means the displacement, this is the displacement. We said the vector, this is the vector displacement, OV. So OV, it is U vector plus V vector. How? If you are asked to find OV, the starting point is O. You want to reach V without going direct on the displacement. So that means without going direct here, you follow another route apart from this direct route. You want to reach at V. So you have to move from O to U, then U to V. So that means OV, we can say it is OU plus UV. So it will be U vector, because the direction is this way and this is the direction. So it will be U vector plus V vector. What if the question was you find VO? Remember VO, the starting point is V and you want to reach at O without going direct. So you'll have to go VU plus U plus UO. So VU, remember the direction is this way. So you are going against the direction. It will be negative V plus, and this one, the direction is that way. So you go against the direction, plus negative U vector, which is the same as negative, it will be negative V vector plus negative U vector if you went against the direction. And that is because you've gone against the direction. Now, we talk about a zero vector. Now, a zero vector, when you move from A to B, if I move from A to B, the direction of this vector is from A to B. If from A to B, let's say the length you walk 3 meters. That is if it is A vector. And then you come back to A, you've gone to B, and then you come back to A. When you go to B is positive A, coming back is negative A. And therefore, when you add the two, A plus minus A, it becomes 0. And therefore, that is a zero vector. A zero vector, it can also be called a null vector, because A plus minus A, it is 0. So that means AB plus BA is 0. AB plus BA is 0, because you go towards B and then you come back and that one is cancelled out, and therefore AB plus BA is 0. And that means that if A plus B is 0, then B is equals to negative A, or A is equals to negative B. Multiplication of vectors by a positive scalar. Assume if AB equals to BC equals to CD equals to A. That is, A to B is A vector, B to C is A vector, C to D is A vector. So that means we have 1 A plus A plus A, that is To get A to D, it is A plus A plus A, which is A plus A plus A, which is 3A. So 3 is a positive scalar. It's a scalar multiple of A. So this is a positive scalar multiple of A. So the vector AD, it is 3A. And 3 is a multiple scalar. It's a scalar. Then a negative scalar, if we want to move from now D to A. D to A, remember the direction you were told is A to D. You want to move now D to A. You go the reverse. It will be negative A plus negative A plus negative A. That will give you negative 3A. So the scalar here is negative 3. Negative 3. So the scalar, the negative scalar does not affect the vector. It only affects the direction. It only affects the direction. The zero scalar, when a vector A is multiplied by 0, the magnitude is 0 times that of A, then the result is 0 vector. So the zero scalar gives a 0 vector. So A times 0 equals to 0 and A equals to 0. So that is what we call a zero scalar. You multiply by a vector, it gives you a 0 vector. A zero scalar multiplied by a vector gives a 0 vector. Now, how do we multiply a vector by a scalar? If K is n positive scalar and A is a vector, then Ka is a vector in the same direction as A, but K times longer. And if K is negative, Ka is a vector in the opposite direction to A and K times longer. That means the negative does not affect the magnitude. It only affects the direction of the vector, as I said before. Let's talk about column vectors. Vectors of the form AB, where A is the horizontal displacement and B the vertical displacement, is what we call a column vector. These are the vectors of the form AB. You must represent them in this form for them to be column vectors. Now, for instance, we have this is A, point A and point B. Point A, point B. So, OA, that is 2, 1, 2, 1 is just a column, in column form will be 2, 1. And 4, 7 in column form will be, this is coordinate, remember, and these are coordinate. But these coordinates, if you represent them in vector form, it will be 2, 1 and 4, 7. Now, to find vector AB, you want to find vector AB. AB will subtract the column vector of A from B. We subtract the column vector of A from B. If you are finding AB, you subtract the column vector of A from B. And if it is BA, then it will be the column vector of A minus that of B. I hope you understand that. That if you are asked to find AB vector, it will be B minus A. If it is BA, it will be A minus B. And therefore, AB vector, we have said, is O what? It will be the column vector of B, which is OB, or B minus OA, which is B was 4, 7 in column form, vector form, minus A, which was 2, 1 in column vector form. You get vector AB as 2, 6. Vector AB as 2, 6. Position vector. A vector that describes the spatial position of a relative to the origin. That is, in relation to the origin. a vector that describes a position, a spatial position in relation to origin is what we call a position vector. So we have to relate to the origin always. Like each 0.47 in our case, in previous case here, 0.47 in our previous case, position vector of this 0.47, which is our point A, is OA, which is 47 minus 0, 0. Remember, O is origin, which is 0, 0. So it is 47 minus 0, 0, which becomes still 47. For a point A in the plane, its position vector OA is denoted by A. In the same way, the position vector of OB is denoted by B. That's position vectors. So, if we say that AB vector will be equal to AO vector. Now, if we want to find AB vector, I've said that AB vector, it is AO vector plus OB vector. Now, from here, from the figure, we want to find AB vector. To get from A to B without going direct, I said we move A to O plus OB. So it is AO vector plus OB in direction form. So this we know is A. Remember, from here to here is A. So the reverse is negative A plus B vector, because we are going towards the direction we are told about. OB is B. So it will be negative A plus B, which is the same as B vector minus A. Now, when you are given the coordinates of AB, there is no, you can either move that like I've said, or just use the coordinates direct, which will be OB minus OA. From the figure, that is A is 2, 3. If A is 2 and this is 3, A is 2, 3 and B is 5, 2. B is 5, 2. B is 5, 2. And therefore AB, you find this coordinate of this, of B. AB is the coordinate of B minus coordinate of A in column form. So AB will be 4, 7 minus 2, 3, which gives you 2, 4. That's vector AB. It is 4, 7 minus 2, 3, which is 2, 4, as the vector 2, 4. Magnitude of a vector in 2 dimensions. When we talk about magnitude, is the length of the directed line segment, length of a directed line segment, meaning a line with direction, a line like this one with direction, this one with direction. We discussed about it. We are going now to show how to do it. A line with the direction. So, a magnitude is a length of a directed line segment. Now, a magnitude, like for instance, magnitude of U is represented as U magnitude with vertical lines in between. With vertical lines is what we call magnitude. And we find magnitude by using Pythagoras theorem. That's to calculate the length of a vector. That is, if U is xy, then magnitude of U is x squared plus y squared. If U is xy, then magnitude of U, it is x squared plus y squared square root. It is x squared plus y squared square root. So example of the one that we discussed above, that this and this had the same magnitude. Now what we do, PQ, to find the magnitude of PQ magnitude, remember we have to get PQ vector first, in column form first. PQ vector, it is Q, that is OQ, it will be OQ minus OP. So we first of all find Q in column vector is the vector of Q minus the vector of P. So vector of Q is 4, 4 minus 1, 2, it will be 3, 2. So vector PQ, which I've said it is column vector of Q minus column vector of P, column vector of Q minus column vector of P, to get PQ as 3, 2. Now we find magnitudes of PQ And we have said magnitude is x squared plus y squared square root, which will be, now these are our x and these are y. So it is 3 squared plus 2 squared square root, which is the root of 13. And if you do this one, is also the same like we said from above, because R, remember its origin is 0, 0. So RS is 3, 2 in column vector form minus 0, 0 in column vector form, which still remains 3, 2. 3, 2 squared, 3 squared is 9, plus 2 squared is 4, square root 4 plus 9 is 13, square root of 13. So they have the same magnitude, and they are pointing towards the same direction, and we said from earlier above that they are equivalent vectors. Midpoint. When we talk about a midpoint like AB, the midpoint is the middle point that divides this line into two equal parts. Now the midpoint divides a line into two equal parts, like I've said, and therefore the midpoint M, for me to find the midpoint, I discussed in another topic, the midpoint, to find the midpoint of a point, it is x1 plus x2 over 2, comma, y1 plus y2 over 2 brackets. So this is the formula of finding the midpoint of a point. So if I want this midpoint M, midpoint of AB, point M, will be -1 plus 5 all over 2 and 6 plus 2 all over 2. That is -1 plus 5 over 2. This is -1 plus 5 is 4 over 2 is 2. And 6 plus 2 is 8 over 2 is 8 over 2 is 4. So the midpoint M is 2, 4. Translation factor. When we talk about a translation factor, is a factor that moves an object in such a way that all its points move the same distance and in the same direction. All its points move the same direction and the same distance from where they are. They move towards the same distance and in the same direction. So that is what we call a translation factor. Now, translation factor, I'll give you a formula that will assist you to calculate, to do some calculations. If you are given a translation or an object or an image, you can find another by using this formula. Image, I stands for image, equals to object, O stands for object, plus T, which stands for translation. So image is equals to object plus translation. An example, find the image of an object P, which is 3, 4, translated by factor T, 5, -2. Remember, the translation factor is 5, -2. Now, to find position factor, first of all, we write P in terms of position factor of P. It is 3, 1. 3, 1 in position factor of P in column form. So, we know that we have been asked to find the image. We know that image is equals to object plus translation, as I said. So, our image will be equal to the image, which is 3, 1, because we are told that image of an object, the object image, we are looking for image, we know the object is 3, 1, plus the translation, which is 5, -2, it gives you 3 plus 5 is 8, and 1 plus -2 is -1. So it is 8, -1. Therefore, the image of this translation, the image of P under translation this gives you 8, -1. Don't leave your answer in this form because this is a vector form. You have to change it into coordinate form. Therefore, the image P image, this apostrophe, the apostrophe means an image. P apostrophe means image. So P image equals to 8, -1. It must be in coordinate form for you to get the answer mark. Now, I want to tackle questions on the topic. Question number 1. Given the column vector A as 1, negative 2, B as 6, negative 3, C as negative 3, 2, and that P equals to 2A minus a third B plus C. You express P as a column vector. I want to express this P as a column vector. Now, P as a column vector would be equal to 2A. So it would be 2 into A vector, and A vector we know is this one, 2 into A vector, then minus a third B, minus a third into B vector, we know B vector is here, into B vector plus C, and we know C is here, that is negative 3, 2. So we add all these, we do these calculations to find P in column form. So first of all, we open the brackets, it will be 2, negative 4. 2, negative 4. And this one will be negative minus, that is a third times this. Negative a third times 6 gives you negative 2. A third times negative 3 gives you positive 1. So it will be 2, negative 4, negative 2, positive 1, and then plus this one. That's negative 3 and 2. Now we do the calculation. 2 minus 2. This comes addition. That will be 4. 4 minus now 1, because this is negative, minus 3. It gives you 1. And then you come on the y side. Negative 4 minus 1. Negative 4 minus 1 gives you negative 5. Now negative 5 plus 2, negative 5 plus 2 gives you negative 3. So P in column form will be 1, negative 3. That is the column vector of P. You determine the magnitude of P. Now that we already have vector P as 1, 3. Magnitude we said is x squared plus y squared squared. So the magnitude of P is 1 squared, which is our x, plus negative 3 squared, which is our y, square root. Square root, all of things square root. So it will be 1 plus 9, 10 is square root of 10. Remember, magnitude must be is the length, and length must have units. So if you are not told the units, you just write the root 10 units, or 3.162 if you find it in decimal form, 3.1622 units. Remember to write the term units because it's essential. Question 2. Given the points P, negative 6, negative 3, Q, negative 2, negative 1, and R, 6, 3. Express PQ and QR as column vectors. We have been asked to express PQ as column vector. PQ as column vector is the same as vector OQ minus vector OP. That is Q minus P. The vector position vector of Q minus position vector of P. This is the position vector of Q minus position vector of P for you to find column vector PQ. So vector PQ, it is the position vector Q minus position vector of P, position vector of Q minus position vector of P, which gives you, for Q, we know Q is here. You write it in position vector form, it will be negative 6, negative 3. Now Q is negative 2, negative 1 in column form. So our PQ will be Q, negative 2, negative 1, minus P, which is negative 6, negative 3. So negative 2 minus 6. This negative becomes positive. So it is negative 2 plus 6, which is 6 minus 2, which gives you 4. Which gives you positive 4. Negative 1 minus 3. Negative becomes positive. So it is the same as negative 1 plus 3, which gives you 2. So the position vector, the column vector PQ is 4, 2. Column vector PQ is 4, 2. QR, position vector QR. To find QR, it is position vector of R minus position vector of R minus position vector of Q. So it is R, we know R is 63, minus position vector of Q, and the Q we know is -1, -2, -1. So 63 minus -2, -1, which is 6 minus -2. Negative negative becomes positive. So 6 plus 2 gives 8. 3 minus -1, 3. This becomes positive. So it's the same as 3 plus 1, which gives you 4. So the position vector or column vector of QR is 8, 4. 8, 4. Remember, this 8, 4 is not a fraction. Some people I know will write fractions when, and this is not a fraction. This is a factor. A factor is not a fraction. Don't write a fraction here. So it is 8, 4, just a factor. It has no fraction. Question 3. Find scalars m and n such that m with 4, 3 plus n negative 2, this is a scalar, negative 3, 2 equals to 5, 8. So these vectors, when you add them together, multiply with the scalars, you add them together, must give you 5, 8. So what we do, we form two simultaneous equations by opening the brackets. So if we open the bracket on the upper, the x side, it will be 4m minus, because this and this becomes negative 3. So 4m minus 3n, which is equal to 5. 4m minus 3n equals to 5. Then the next one is 3m plus 2n, which is equal to 8. 3m plus 2n, which is equal to 8. Then we solve the two equations. These are two equations. We solve them simultaneously. Like I said from previous topics, now I want to eliminate m. For I to eliminate m, I multiply the above the upper equation with the coefficient of m of the lower equation, which is 3 in this case. And then I multiply the lower equation with the coefficient of m of the upper equation, which is 4 in this case. So when you open these brackets, it will give you 3 times 4, it gives you 12m. 3 times 3, it gives you minus 9n. Then 3 times 5 gives you equals to 15. You do the same with the lower equation. It is 12m plus 8n equals to 32. Then I want to eliminate this. I want this one to be 0. So the only thing I can do here for this to be 0, I subtract. If I subtract 12m minus 12m will be 0. So this will be 0. Then I'll have negative 9n minus 8n. Negative 9n minus 8n, it gives you negative 17n. So negative 17n equals to 15 minus 32, it is also negative 17. So negative 17n equals to negative 17. We divide by negative 17, we divide by negative 17 in both sides, it will give you n equals to 1. So you come with your n as 1. If I use this original equation, I substitute 1 here, like I've done here, 4m minus 3n equals to 5. That's the original equation that I had formed here. So if I substitute n with 1, then it will be 4m minus 1. 4m minus 1 times 3 is 3. So it is 4m minus 3 equals to 5. 4m minus 3 equals to 5. Like terms together. This goes the other side. It is 4m equals to, because it becomes addition, equals to 5 plus 3, which is 8. 4m equals to 8. You divide by 4, you divide by 4. Our m equals to 2. So the scalar m and n are n equals to 1 and m equals to 2. You've answered the question as required. Question number 4. OAB, this is my OAB is a triangle. A is the point 28. A is the point 28 and B is the point 10, 2. This B is the point 10, 2. C, D, and E are midpoints of OA. C, D, and E, C D, and E are midpoints of OA, OB, and AB respectively. Now, find the coordinates of C, D, and E. Coordinates of C, D, and E. For coordinates, remember, for midpoints, we have the formula of finding midpoints. X1 plus X2 over 2, Y1 plus Y2 over 2. So to find my C here, it is 2. Remember, here is 0, 0. Origin is 0, 0. O, origin is 0, 0. So being 0, 0, it will be 2 plus 0 over 2, 2 plus 0 over 2, and 8 plus 0, 8 plus 0 over 2. So that is the coordinate of C, which gives you 2 over 2 is 1, because this plus this is 2. 2 over 2 is 1. 8 over 2 is 4. So the coordinate of C is 1, 4. And the coordinate of D, it is also to the respective with the origin. So we have 0, 0 and 10, 2. So it will be 10 plus 0 over 2 and 2 plus 0 over 2. So 10 plus 0 is 10 over 2 is 5. 2 plus 0 is 2 over 2 is 1. So the coordinate of D is 5, 1. The coordinate of E, I'll have, because I have told is the midpoint of AB. So it will be 2 plus 10 over 2. 2 plus 10 over 2 and 8 plus 2 over 2. 8 plus 2 over 2. So 10 plus 2 is 12 over 2 is 6. And 8 plus 2 is 10 over 2 is 5. So the coordinate of E is 6, 5. Then find the length of the vector CD. Find the lengths of vector CD and AB. Now, first of all, you have to find vector CD. Vector CD, which is equal to OD, vector CD equals to OD, that is position vector of D minus position vector of C. Position vector of D minus position vector of C. So it is D we got as 5, 1, 5, 1 minus that one of C we got as 1, 4 minus 1, 4. So it gives you 5 minus 1 is 4, 1 minus 4 is negative 3. So CD vector is 4, 3. So CD length, which is modulus, CD modulus will be 4 squared plus negative 3 squared. That is 4 squared is 16 plus 9 gives you 16 plus 9 gives you 25. And the square root of 25 is 5. So CD length, it is 5 units. CD length, the length of CD equals to 5 units. Because it's 4 squared plus negative 3 squared square root. Now, we also find vector AB. Vector AB will be equal to OB, that is the position vector of B minus position vector of A. Position vector of B minus position vector of A, and B, we know position vector of B is 10, 2. So it is 10, 2 minus position vector of A, which is 2, 8, minus 2, 8. So you get as 8 and negative 16. You find as 8 and negative 16. AB vector is 8 and negative 16. And therefore, I want to find the AB modulus, to find the length of AB. It is 8 squared. It could be 8 squared plus. It will be 8 squared plus negative 6 squared plus negative 6 squared, which gives you 100. So 100 square root of 100 is 10. Therefore, the length of AB is equals to 10 units. Remember to write the term units. So the length of AB is 10 units. So the first thing you want to do is to find the position vectors of CD and AB. After finding the position vectors of CD and AB in column form, of course, then you find the modulus of them to get the lengths. Question number 5. The image of 0.64 is 34 under translation. Find the translation factor. Remember, you are told the image of this. So this 64 is the object and 34 is the image of this one under translation. And I'm asked to find the translation factor. The formula I gave you was image equals to object plus translation. So this means if I take all this other side, then translation, I make t the subject of the formula, then translation would be equal to image minus object. And my image here is 34 minus the object is 64, gives you negative 3, 0. So the translation factor is negative 3, 0. That is the translation factor. This formula is very essential for translations. Question number 6. In a triangle OAB, MN are points on OA, M and N are points on OA and OB respectively, such that O to M, and M to N is 2:3. 2:3. So that means if this is 2 and this is 3, the whole line is 5. The whole line is 5. And we are also told that ON to NB, it is 2:1. So that means the whole line is 2 plus 1, which is 3. The whole line is 3. Given that OA is A, O to A is A factor, and OB is B factor, O to B is B factor, you express in terms of A and B vector BM and AN, vector BM and AN. Let's start with BM. I want to move from B to M without going direct. The easiest way, of course, you can come this way and then you go that way, but you don't have BA unless you start finding. And then why are you giving yourself stress of finding BA first? And we know BO. So for the easiest way, you move from B to O, which you already know, but remember you're going against the direction you are given. You are given direction OB. So it is BO plus OM, which will give you BM. So our BM equals to BO, like I've said, plus OM. BO plus OM. That gives you BM. And the BO is negative B because we are told that OB is B. So BO is negative B plus OM. And OM, remember we were told the ratio is 2:3. So O to M is 2 of the whole line. That is 2 over 5 of what? A. Because we know of OA. And OA we know is A. So it is negative B. That is negative B, BO is negative B, plus 2 over 5 of OA, 2 over 5 of OA, which would be equal to negative B plus 2 over 5A, which is the same as 2 over 5A minus B. Even if you leave it in this form, it's still correct. Even if you leave as negative B plus 2 over 5A is correct, or 2 over 5A minus B is still okay. AN. I want to find AN. To move from A to N, because if I go this route, I'm then required to find AB first. So I leave it because I don't want to stress myself. So I'll have to move from A to O because you already have it. A to O, then O to N. So it will be AN equals to AO, which we already know because we know OA. If we know OA and you are going against the direction, then it will be negative. So it will be AO is negative A factor plus ON, which is 2/3. Remember, the whole line is 3 because it is 2:1. So the whole line is 3. So it will be 2 over 3, 2/3 of OB, and OB is B. So it is negative A plus 2/3 B. Negative A plus 2/3 B. That is the correct, or you get it as 2B minus A is still correct. So that is factor AN and factor ABM. I hope the video has been helpful to you, and I want to thank you so much for watching this video, and God bless you. Remember to subscribe this vector. Thank you.